So hello everyone. My name is Dario, and here is my colleague, also Dario, and we are going to present open source automation and monitoring in enterprise environment. We are aware that we are the only thing that's between you and your coffee break, but we promise that we'll be short, brief, and hopefully educational. We come from a medium-sized IT company located at the edge of the city, which is quite old one. It has more than 50 years, so that's older than the internet itself. So you have to assume that a lot of historical baggages were in our company. So we wanted to apply some open source automation and avoid the future vendor lock-in. So to give you a huge to give you some brief, let's talk something a little bit about us. So we were started something around the 1960s, and IBM was our main delivery. We were mostly responsible for accounting and financial services for the city of Zagreb, but after the Yugoslavia collapse, we took the responsibility for all Croatia. One of our most important tasks were IT support of university games in Zagreb in 1987, and here you can see how we used to deploy some huge machines in our warehouses. But after all these years, we come here. But and we were going to talk how evolution is completely different in enterprise environment when we compare it to some startups. When you're starting startup, you can basically start from scratch. But when your company is more than 50 years old, you basically can't do that. You have path dependency cost. It's really expensive. And we took one example to show you. What do you think? What is the most important thing? What important thing in your job as IT? The most important thing is of course documentation. You don't have to raise your hand if you at once keep documentation in your head, but I know you do, so that won't be necessary. I admit I did it at once, and we can just check how the documentation is usually evolved in companies. At first, you have some crazy smart guy who remembers everything in his head. So afterwards, the boss comes and says, "You can't do that. Sorry, you might be hit by a bus or go to another company." So you're forced to save something in Notepad, but at first you save it on your computer because that's your knowledge. You don't want to share it with others, and afterwards. You have shared documents on some network drive, but has anyone shared Word documents with others? That's really not user-friendly. So the next logical step is a local wiki page, or thanks to Aaron Schwartz, markdown documents. But you would say, you might think that there isn't something after local wiki, but can we have documentation that evolves as our code evolves, and that's something that we implemented. It's called Ansible. So, actually, we endorse it in our environment. When we're talking about our environment, the environment is quite large, and that's actually what helped us to introduce some automation tasks. Because if we were a small company, we wouldn't be forced to do that. And you can see a large portion of our environment is Linux-based, but it is Linux-based, but it's also heterogeneous. It's different OS versions and different architectures. So, how documentation evolution looked in our company? At first, of course, comments copied in Notepad. Afterwards, we move it to Git, so multiple people can actually collaborate on it. And afterwards, we simply move to Ansible. The most basic task is deployment of a new machine. It's actually that's the most repetitive task in our company, because you saw that we have a lot of servers, and the server itself can't be alone in the world. He has to be connected to some other components, and at first he has to connect to a foreman. It's basically a proxy or cache for repositories. Secondly, he has to be connected to an identity server, which offers him identity manager and also a clock. Third, he needs to be connected to some monitoring system. In our case, it's AWX. At first, he has to be connected to something that keeps tracks of logs. In our case, it's Splunk, but it can be something different. The fifth one, he has to be connected to license metric tool, and afterwards, backup system. And you can see that it has to be connected to a lot of things. And if you're requesting a lot of machine, the deployment, the time to deploy a new machine can take a huge amount of time. And why don't we automate this? But when the new machine is born, it's actually born from a template. But a lot of things that I mentioned on the previous slide can be embedded in a template, but not everything, because you don't want to put something statically in a template that you will replace afterwards, or it's something that depends on your architecture or as a version. So what is included in the template? In the template is included something that is the most global thing. So configure of mount points, installing some essential packages, net tools, telnet, and etc. Configuration of a grub in our environment, it's something special for us. But also the configuration of a local user, which is used to initialize the automation procedure, and of course something that's not negotiable, the machine hardening. Everything else that was on the previous slide is done with Ansible, and my colleague Dario will take you on a path towards that Ansible playbooks.
Thank you very much. Thank you, Dario. So, so what is Ansible? Firstly, Ansible is open source automation engine. So basically, on your server, you have your Ansible installed. On your server, you would install your Ansible, and Ansible can connect to your host that you will be automating via SSH. You define the list of those hosts. You define the list of those hosts inside the inventory, and then you're pushing your configuration via YAML. Configuration is written in YAML. We have something that is called a playbook. So basically, why would you use Ansible? There are a couple of points that you would use. So the first thing is that it uses something that is called agentless architecture. So the nodes themselves don't need to have any agents installed. The only thing that needs to be installed is the Python. So this is the only thing, and you have to have a SSH connection to the nodes. So as you are using the SSH connection, it means that the connection is encrypted by default. It uses a clean and easy syntax written in YAML, as you will see a little bit later, and it uses two very important ideas. The first one being the idea of idempotency. So it's something in math that can be translated that when you're running your playbooks multiple times, playbooks can be run multiple times without changing the results beyond the initial application. So don't do changes if changes are not necessary on the service. And infrastructure as a code, this is the idea that you should write your configurations of your service in the same way that you will be do them during the standard software development process, so with primarily with versioning in mind. So this is very important. Okay, now we will show you a couple of examples of playbooks that we use. Before we do anything, we do a couple of pre-tasks. So the pre-tasks are important because we gather facts about different variables, so we can use them later in the playbook. So in this example, at the top, we define which environment should this server belong to, and we are doing that by querying the internal Ansible variable, Ansible hostname. We are doing the regex on it, and as we have our service, and we have a standard name nomenclature for our service, we can see by the server name which the environment it should belongs. And this we do for all other environments, and at the end we just on this example we are querying the OS version so we can use it easier. And we are also querying the variable Ansible distribution major version in this case. So this is internal variable. You can see you can use those variables anytime, and you can rewrite them to your own namings. Okay, so this is my colleague Dario has shown earlier. These are the first two steps when we are doing our host registration. So you need to connect to your foreman. This is the subscription management service, Red Hat Satellite. And of course, you can. The next one would be registered to IPA. Those two, the IPA server for identity management. So these two, as you can see, these two examples are basically very similar. So for independency's sake, you want to check if this server is already registered to the foreman server. If it is, you want to skip everything else until this line. So you're doing a simple script. In this case, you're doing the shell command subscription manager identity, grabbing the CCV, and then counting the lines. If the lines return something, then you know that you are registered. And otherwise, you are not registered, and you can register this value to your own variable. In this example, the name is register hint. Afterwards, you download the Catelo using the get URL. Download the Catelo agent from the foreman server. You install it by using the YAM module, and then you can do your subscription manager register command using the activation keys that you defined on the host level. And this is all done inside the block, and only when you have determined that this host is not registered to the foreman server. So this is how you preserve your idempotency. Next one is very similar, so I will not go into detail, but you also, this is registration to IPA. You do your checks at the top. You install in this example using the YAM module. You can install IPA client packages, and you do your IPA client installation domain. This is the variable that you define on the other level, and then you use your user that has the rights to enroll users, and password can be stored in Ansible Vault. We have a couple of more examples. So this is the example of something very familiar, and this is NTPD service. So in our environment, okay, we have RHEL 7 and RHEL 8 templates. So in our environment, RHEL 7 templates use NTPD service. So in this example, we need to make sure that this service is stopped. So we're using a service module, check the NTPD, ensure that this service is stopped when OS version equals 7. So this is the variable that we have gathered in pre-task, if you can remember a couple of slides ago. And then we are installing Crony to the latest version. We are removing the existing configuration inside the Crony configuration file by using the line in file module. We are making sure that lines that start with server are absent for this file. So very simple. And then we set up our own service with the same module. We are using line in file. We are iterating through Crony servers array, and then we are iterating the items inside server, item, iBurst, and then after all is done, we restart Crony service, and everything is fine. Okay, this is an example that you will do during the host preparation. You can also do it during the standard patch management service. So updating server, very simple one, but important, of course. So you are doing the subscription manager refresh at the top. You are cleaning the YAML cache, updating all packages, and give enough time to server to update itself. And then, very important step, you are checking if the new kernel is installed. So this is the independency one where you don't want to do changes if you don't want to restart the server if kernel was not installed, new kernel. So you are comparing if the last kernel is the same as the current kernel. If it is, so you don't need to reboot, kernel is current. Otherwise, echo reboot inside the variable reboot hint. And then restart system to the newest kernel if this output as a standard output of this variable equals the one that you expect reboot. And you can also define your own values that you will specify during you will see this later also. If you can override this with the variable reboot answer equals null. Sometimes you don't want to reboot the service after the update. Maybe you want to wait until the current until the patch maintenance period. And of course, you wait for the system to reboot as the last example. Okay, this is the one that we do on our Power Linux service. So Linux on Power, we treat them as in the same way that we treat physical servers, because they run as LPARs, and we don't back them up as the same way that we do our x86 service on VMware, where we use VMware backup mechanisms underneath. So we do our backups of them using RARE. So this is the relax and recover for backupping Linux service. Okay, we have two versions for Linux version 7, for Red Hat version 7 and 8. As the package name differ, we have two tasks: installing the RARE packages. Then we copy our configuration file that we have prepared earlier to the RARE config configuration file. Then we are creating the temporary directory that will be used during the backup process. Then we are creating the log directory, of course. So you can see you are using the file module, state directory, var log RARE, where we want to create the directory. As we monitor our backups with Zabbix, we want to give Zabbix rights to access log files inside this directory that we have just created. So we are using HCL model to give the right permissions. And then we have to deal with say Linux, of course. So we have to create modules directory, same thing for the say Linux, and then copy the model that allows Zabbix user to read the files inside this directory, and we are copying it to the modules directory. We check if this module is already loaded, so we don't load it twice. With same module list command, we get all modules. We can register this to modules variable, and then we can check if the standard output of the variable modules, we can try to find the name that we expect. Is this example Zabbix varlog t? If this is present, we don't install the module. Otherwise, we install it with say module. And of course, at the end, we make sure that cron jobs for backups are present, and this is very simple. So you can see that based on the environment, we have there two examples. One environment does its backups at 6 a.m., another at 5 a.m. You might ask yourself if there is a GUI. Of course there is. The name of the GUI is AWX. This is an open source project behind Ansible Tower, and it gives you the web user interface over the whole Ansible automation engine. So it gives you ABAC model for role-based access control that you can use, you can connect it to your LDAP server, and then you can define which users on your environment can do which certain runs of jobs. So you can define something that is called job templates, where you will mesh up together credentials, inventory of hosts, and the playbooks, and then those jobs can be run at scheduled intervals, or you can run them just at the point of the click. And everything could be automated through an exposed API, so that external services could can connect to the AWX server and run jobs. We will show how we do that a little bit later. You can do, as I've said, you can do schedulings and notifications, and you have real-time historic jobs that you can query from, that you can review later on. And one important thing that we will show, that you can give your users that start a job option to do a drop-down menu for the certain variables that you defined earlier. So this is the example of when you launch a job. So you're presented with something like this. You can define the credential, you can define the inventory. You can limit the certain hosts inside this inventory. If this inventory contains a lot of hosts, you can limit it on a few. And then you can include or exclude certain Ansible playbooks using the tags. And also this is where you can overwrite or add extra variables that you would use inside your playbooks. And this is how it looks when you start a job. This is your standard Ansible output where you can see which job is currently running, which has run, which job finished without changes, with OK status, and where or if anything was changed, you can see it here. Also, you will see here a failed status if there were any some. And this is an example of a survey. So you can, from a drop-down menu, you can present it as a drop-down menu where user can choose. So I will give helm back to colleague Dario. He will tell you more about how we have implemented our Zabbix monitoring solution that we use to monitor all our infrastructure and services, and how we have implemented it with AWX, so we can automate jobs based on the triggers that are triggered on the state of Zabbix. So thanks for now.
So when you're implementing the monitoring system, you of course you want it to monitor your system, but you also want some actions to occur when the system is in high utilization, and monitoring system can tell you that. So why don't we integrate monitoring system with something that can run tasks on idempotent tasks on servers? So in one of our use case, we have 2 Tomcat servers, and they are in high utilization. Their memory is very, very high, and it can run into server collapse, and OM killing everything. So we have Zabbix monitoring set it up, and when Zabbix detects high memory utilization, Ansible will run task which will sequentially restart each Tomcat. If it's the first one, and if it's sure that it's completed and started, and then the second one. And afterwards, it can send a message to the admins if it succeeded or if it didn't succeed. Dario previously said that AWX provides us extensions, and here you can see on one example. Even though we run our playbooks through GUI, we can still run our playbooks using command CLine, which you can see down there. Tower CLI job launch, which job on which in inventory. And here you can see a playbook example which stops the Tomcat service. Afterwards, it starts, and then it checks in regular intervals when the Tomcat app is launched, and then it can go on the another one. That's because we have a serial on the left side when the whole playbook configuration is set serial to 1. That means that each server will be run one by one, so sequentially. So we are at our final thoughts. We can say a lot about automatization. It also has advantages and disadvantages. One of the advantages is that it has low time of machine initialization, and we are as humans hate repetitive tasks. We aren't computers, and it's also a huge help when you're dealing with large scale deployments. And it also can be used a script as a documentation because it's always up to date. Of course, anyone can do it, and if you save some time doing that, you have more time for security, which is always lacking. But on the other hand,
of course, there are disadvantages. So you won't want to do to automate something that you don't know how to do manually, but it does because it doesn't make sense. It is harder for new team members that come to our company to understand what is really going on in the background if they don't have it in their fingers. When you do some errors, when you make errors and you push it to the production, let's say the errors are easily multiplied on a large scale, so you can have your whole production down by the tip of the finger. And it also is sometimes time consuming to write new scripts, and maybe if you're doing something that is not repetitive, it doesn't make sense to automate it if you will be doing it only once in let's say in 1 year. So then it is easier to do it manually on the couple of servers. And this picture, you can see these were the Ludities, and they were the secret oath-based organization of English textile workers in the 19th century, and they protested against manufacturers who used machines in what they called a fraudulent and deceitful manner to get around standard labor practices. So they were afraid that the time spent learning the skill of that craft would go to waste, as a machine would replace their role in the industry. So the bottom line is, don't be like them, and don't be afraid to click, because fear is the mind killer. Thank you for your attention. If you have any questions.
It's Zabbix monitoring is specific virtual machines, and and that's a specific virtual machine just for Tomcat, in this sense, and it's mostly 99% cause on that machine. So.
Excuse me, how long did it take? We were doing it in process, so altogether probably a year, maybe 3 months to write it initially, and then iterations to clear any errors. Of course, when the new server version arrives, let's say we were migrating from Red Hat 7 to Red Hat 8, of course we needed to do tweaks, and every time we need to do tweaks when there are any kind of changes in our environments. Yeah. No, this is the image backup. So we are using Relax and Recover to do image backups, and we are using TSM to do file system backups. So we have both installations of both softwares are automated, but we only use them on Power Linux servers because we treat them, and of course on physical servers because we treat them the same.
Can we use other monitoring solutions beside or before Zabbix?
have used Nagios before, not in this company, but I have. And in Apis we used Microsoft's solution before, and then we switched it to Zabbix, and to Zabbix for at least for Linux and Unix and Unix-like service. So we are still monitoring Windows service with Microsoft solution. So this is. Yeah. Yeah, we.
What happened if the kernel is changed? Then it will be automatic. But if you want, when you're launching a playbook, you can specify that you want to reboot your machine, but the basic behavior is only when the kernel is changed, it will reboot 100%. But sometimes you want to apply upgrades, but you want to reboot your machines in some service times. So, example, in 6 a.m. in the morning.
Yeah, there's a script in it's called needs restart. So you can use that instead of the kernel check and it checks the whole system.
This is a great advice. Thanks. We will check that. Excuse me, I didn't get it. Did you ask a question or no? No. Thanks.
So as I understand, you are doing custom configuration of the initial virtual machine, let's say it's a virtual host, with Ansible.
Yeah.
But I didn't completely understand, are you making automated provisioning of the initial machines, or is it done manually?
No. Yeah, of course. So the initial provisioning is not on the VMware's. We have a template on the VMware site. VMware admins they use Cloud Init to push the initial IP address and DNS service, and of course host names. Those three things are pushed from the VMware site, and everything else then we take over from the Ansible site. When you have your network up, you have the user on the template that you use as an initial user before you are connected to the IPA, and then at the end of the run you delete that user as additional security feature. So initially, Cloud Init is used from the VMware site to configure hostname, IP address, and DNS service.
The VMware team is doing this manually, or do they have some automation tool for that part?
I'm not sure if they're using VMware. So when there is one server that needs to be configured, I'm not sure about that. So, yeah.
Because I know that Ansible has a module that interacts with VMware API, and Ansible is able to provision the machine from templates automatically, give a host name, IP address, so you have a live host after Ansible is done. This part can also be covered by Ansible and incorporated to this other stuff that you're doing to get the final configuration of the server.
Yeah, thanks.
I saw that you use format. So what do you use format?
Format for subscription management, primarily Catello in the format. So we use it to publish the repositories to the hosts, Linux hosts. So primarily Catello inside as a model inside format.
When we are patching our machines, the machines pick up the latest packages from the format. If this is it, thank you very much.